Hi everyone, in this lecture we will solve one problem of fast exponentiation, right? So we will see how we can compute a raised to the power n using bitwise operators, and that too in an efficient manner, right? So question is, given two numbers a and n, we want to compute a raised to the power n, right? So this can be n. So for example, if a is 3, b is 5, then we want to compute 3 raised to the power 5, which is 243. So what we can do, we can say, okay, one way is you multiply 3 5 number of times, but that is going to take order n times, so we are not going to do this, and because this is inefficient, right? So what we will do, let's try to visualize. Let's say we want to compute a raised to the power 5. So in the first step, we will visualize this 5 in the binary form. So in binary it is written like this, and we also know when we write binary, this contributes 2 raised to the power 0, this bit contributes 2 to the power 1, this contributes 2 square, and this is how it becomes 5. So it is a raised to the power 4 plus 0 plus 1, something like this, right? Okay, so if you want to compute a raised to the power 5, what we actually need is, we actually need to multiply a raised to the power 4 with a raised to the power 0 with a raised to the power 1, right? So this actually makes a raised to the power 5. And we also know, given any number n, the maximum bits in any number n, right? So here n is 5, the maximum number of set bits in any number will be log of n, right? So this is going to have log n bits. So somehow if we are able to iterate over these bits, and correspondingly if we are able to generate some powers like this, a raised to the power 1, a square, and a raised to the power 4, right? And what we can do is, the places where there is a set bit, at this place and at this place, right? Let's skip this one. We can multiply the corresponding powers. We can say, okay, a raised to the power 4 will be multiplied by a raised to the power 1, and this will give us a raised to the power 5. So this is the very overview of the technique that we are going to use, and let us discuss the same with the help of one example. So now, for example, a is 3 and let's say n is 5. So what we can do, we can say, okay, a raised to the power 101, this is what we are going to do. We will say, okay, let's keep current answer, which is equal to 1, right? Because something raised to the power anything will be greater than equal to 1, right? So this is my initial answer. So I get this bit, and I also keep a variable, let's say I keep a in the memory, right? So let's say a is 3. So I see if this bit is 1, so I will multiply my answer with this number, right? So this number is a raised to the power 1. So 3 raised to the power 1 is 3. Okay, next time I discard this bit, I go to this position, I see this bit is 0, so I do not do anything, right? So if bit is 1, you will multiply your answer with the current value of a, whatever is the current value, right? And if the bit is 0, don't do anything, okay, skip. And in both of these cases, when you're going to move to the next position, you're going to square the previous value of a, right? So in the next iteration, you have 3 as 3 square. So this is done. Now you go to the next position and you square the previous value, okay? So you say a is now a into a, which is 3 raised to the power 4, right? Because this number is 9 and 9 into 9 is 81, right? So once you come to this place, you have a raised to the power 4, and you see this bit is 1. So if the bit is 1, you will multiply by current value of a. So you are going to multiply it with 3 raised to the power 4. So you already have 3 in the answer, you multiply this with 81, so this becomes 243. And this is how we can solve this in order log n time. So let's discuss one more example. Let's say we want to compute 2 raised to the power 6. So what I will do, I will have a, which is 2, and 6 can be written as 110. So I see this bit is 0, so I keep my answer as 1. I discard this bit, So here I have a as 2. I go to next place, I square my previous value of a, I make it 2 square, and I see this bit is 1, so I multiply it with 2 square. So this answer as of now it becomes 4. So next time I go to this position, I say okay, whatever is the previous value of a, I square this up, I get 2 raised to the power 4. So this is 2 raised to the power 4, and since this bit is 1, I multiply my answer with 2 raised to the power 4. So my answer becomes 4 into 2 raised to the power 4, which is 16. So this becomes 64. Okay, and you can verify multiplying 2 6 times will give you 64, right? So this is 64. Okay. So this is how you can do exponentiation in log n time, because given a number n, it will only have log n bits. So this can be represented using log n bits. Okay, and we are just iterating over bits all the time. So let's see how we can do this in the code. So this will be a if else condition, and in the general case we will have something like a will be getting multiplied by a itself, and we will be right shifting the value of n equals to n right shift 1 if we want to discard this bit. So these will be part of the loop. So let's see. So let's start with the initial value answer, which is 1, and we can say okay, while n is greater than 0, because we are extracting bits from n, we will say okay, whatever is the value of a as of now, we will multiply with the answer if the current bit is 1. So we can say okay, what is my last bit? Last bit is given by n and 1. If last bit is set, then I can say okay, multiply my answer with the current value of a, and for the next time I will update my value of a by doing a square operation, and I will also update the value of n by doing a right shift. That's it, and let's return the answer. Okay, so that's how we have written the code, and let's test it. So if I give 2 and 4, sorry, we have not printed the answer. Yeah, cout, let's say power optimized a and n. Okay, so let me give 2 and 6. So this makes 64. Let me give 2 and 10, and let's say 3 and 5. So all the answers are correct, so which means our code is working fine. So the only thing we have to do is, if the last bit is set, we have to multiply answer with the current value of a, and every time we go to the next bit position, we will square up the value of a, and we will also discard the last bit of n. So this is how we are using a while loop over n, and we will do this while n is greater than 0, right? So that's all for this video, guys. Thanks a lot.